Here's a quick video summary of lesson 65, which is the exponent rules. So this is a throwback to Algebra 1, when you originally learned the exponent rules, possibly even 8th grade math. So I'll go through these real quick. I'll give you an example of each. I'm going to do them all right on the page in the interest of time. Now the zero property is that anything raised to the zero power is equal to 1. So some examples of that. 3 to the 0. Yep, that's equal to, 3 to the 0, that's equal to 1. M to the 0, I don't even know what M is, still going to be equal to 1. Something more complex, like 2x plus 3 raised to the 0 power, doesn't matter what's inside, still going to be equal to 1. The product property. The product property says that if we're multiplying two things and they have the same base, then we can add their exponents. So I'll give you an example of that from the first section. By the way, these handouts can all be found on my website, mrjcostello.com. Go to Algebra 2 Files, and they're all there. So if I wanted to do something like this, like question number 1 here. 2 times 3 is 6. And then x to the 0, x to the 2, that's going to be equal to x to the 0 plus 2, which is just 2. So my final answer would be 6x squared. And let's go down one. Question number 3. 3 times 4 is 12. And I'm going to add these exponents. Negative 3 plus 4 is going to be 1. So v to the 1. Or you could just write v, because they're the same thing. If I wanted to do question 5, 2 times 4 is 8. The b's, 2 plus 1/2. I'll leave it simple for now. 2 plus 1/2 is 2.5. We'll leave it like that. In actuality, it should be a fraction, but that's tying into another lesson. Now the power property says that if you raise something to two different exponents, exponent here, another exponent here, what we're doing is we are multiplying those exponents together. So I'll give you a quick, easy example of that. If I had like a x squared to the 5th power, well, it's exponent and another exponent, so this is going to be 5 times 2. This is going to be x to the 10th. And lastly, for this side of the page, is negative exponents. A negative exponent will turn something into its reciprocal. It'll put a 1 over it. So I'll do a couple examples in this section. If I have an exponent on the outside, I've distributed onto every base. So this is equal to 4 squared. X to the negative 2 times 2 is negative 4. Okay? I can simplify this in a couple ways. 4 squared is 16, right? X to the negative 4th, well, I don't necessarily like it as a negative 4. So what I can do is I can put it over a 1, and I can move this down. And if I move it down, it changes the sign on the exponent. So 16 over x to the positive 4. If you want to make something positive or negative, the exponent, moving it up or down on the fraction will change the sign on its exponent. So for instance, if I had, let's think of a real easy example. I'll make this one an orange. This is not on the page, this is just an easy example. If I had something like this, like 5 over x to the negative 4, and I throw a y to the square on top. Okay? Now if I want everything to be positive, what I can do is I can take the exponent that's negative, and I take that whole term, and I move it up to the other side, and it'll become positive 4. And now it's gone, and that would be my final answer. Okay, so moving things up or down is a good way to change the sign on their exponent. Let's do question 11 as well. I'm going to distribute the negative 3. So I get 3 to the negative 3, x to the positive 3. Negative 1 times negative 3 is positive 3. And now I want all my exponents to be positive, so I want to get rid of the negative one. How would I get rid of a negative exponent? But to move it down to the bottom of the fraction. So the x to the third gets to stay on top, and the 3 to the negative 3 becomes 3 to the positive 3 on the bottom. And then if you check your calculator, 3 to the third is 27. So my final answer would be x third over 27. If that seemed a little complex, try an example or two from this section before you move on. Just pause the video. And lastly for this, I know it seems like a lot, but it's because technically this is a review from Algebra 1. The quotient property. Well, there are two ways to think of this. If you have something on top and you have something on bottom, you can subtract top exponent minus bottom exponent. So division turns into subtraction. Now I want to give you some easy examples of this before I go moving on. I want to show you two different ways to look at this. I'm not going to do this with an example on the handout. I'm going to make this up myself, okay? So you can think of it as subtraction. And if you do it that way, I'll give you an easy example. If I had something like this, x to the 9th over x squared. 9 minus 2 is 7. That's one way to do it. If I had something a little different, if I had x to the 4th over x to the 11th, that's equal to x to the 4 minus 11, which is x to the negative 7, and in order to make that positive, I've got to move it down, so I get 1 over x to the positive 7. Now this only gets complicated when you have a lot of things going on. So let me give you an example that's got a little bit more. So if I had 2 over 4, I had an x to the 4th on top and an x to the 2 on bottom. I've got a y to the negative 3rd on top and a y to the 6th on bottom. Now if I wanted to do this example, first thing I'm going to do, 2 over 4 can be simplified. That can instead become 1/2. X to the 4, x to the 2. 4 minus 2 is x. 4 minus 2. Yeah, 4 minus 2 is 2. So I'm just going to write that as x squared. I guess I can leave it for another step in case you want it. And y to the negative 3 minus 6. Rewrite this. 1/2 x squared y to the negative 9th. And then I can't leave it there. It's negative, so I move it down and it becomes y to the positive 9. And then this could be my answer here. Now there's one other way to think of this. So I'll rewrite the same question, just do it in a different color. 2x to the 4th, y to the negative 3rd, over 4x squared, y to the 6th. The other way that you can think of this is 2 to the 4 is still going to just get simplified into 1/2. What I like to do is I like to move the smaller power of whatever variable. So if I'm looking at the two x's, for instance, so I got x 4th and x squared. what I'm going to do is I'm going to move the smaller power up. That will change its sign, so it becomes x to the negative 2 up top. Now if I want to look at the two y's, which one of these is a smaller power? The negative third is. So if I move that down, I get y to the positive third. And it's gone from up there now. So let's tally up what we have. I've got x to the fourth, x to the negative 2. On bottom I've got y to the sixth, y to the third. And now since they're on the same side, I'm multiplying them, which really just means add the exponents. So I've got 1, 4 plus negative 2 is 2, 6 plus 3 is 9. I don't really need to write that 1, but I could if I want to, and either way I'm going to get the same exact answer, which is 1x squared over 2y to the ninth. So you can choose if you want to subtract the exponents or if you want to move them across the fraction line and then add the exponents instead. Okay, it's totally up to you, but all of your answers need to have positive exponents in them. So let's do one example from the page. And we'll do one in each method, one in each direction. So let's do 15 and 16. For 15, what I'm going to do is I'm going to use the move it up and down method. So this is an x to the 1 on bottom. Out of the x's, these two x's, which one has the smaller power? And the x to the 1 does. So I'll move it up and it becomes x to the negative 1. Out of the y's, which one has the smaller power? The y squared does. So I'll move it up and it becomes y to the negative 2. Now since these are both gone on the bottom, we leave behind a 1 as a placeholder. What do I have on top? I've got x to the fifth, x to the negative 1, and for the y's I've got y to the sixth, y to the negative 2. And now since they're on the same side, I could just add their exponents. 5 plus negative 1, that's going to be 4. 6 plus negative 2, well, that's going to be 4 as well. And that's all over 1, which you don't even really need to write. So that would be my final answer. If you want to do it the subtraction way, it's fine. This still has a 1 on it. What do I get? I get x to the 2 minus 1. And I get y to the 5 minus 4. Now 2 minus 1 is 1. So I get x to the first. And 5 minus 4 is also 1. So my final answer is actually just xy, and nothing needs to get moved up or down in the fraction. So it's up to you whichever way you want to do division of exponential terms. Try some from the assigned homework from lesson 65, try some from this practice section to make sure you got it.